Okay, so we're gonna put this is day 2 of the ellipses note. And it's gonna ask you to put this in standard form of an ellipse, right? Now, the first thing, remember, an ellipse has to be equal to 0. So we're gonna group the x's and group the y's, right? I mean, not equal to 0, I'm sorry, equal to 1. So we're gonna first group the x's and group the y's and then go from there. So I'm gonna take my 4x squared plus my 16x. And because it's an ellipse, it's always got a plus in the middle. And then my 9y squared minus my 54y, and I'm going to move the 61 to the other side. I know it needs to be 1 over on the right-hand side, but it's not quite ready for it yet. But our goal at the end is to get that. Now, the next step is to complete the square. You cannot complete the square when there's a leading coefficient, right? You're not allowed to have that. So on the x's, what are we going to take out? Good, a 4. And you end up with x squared plus 4x. And on the y's, you're going to take out a 9, giving me a y squared minus 6y. Then you actually have to complete the square, which we've done a lot, so you're probably much better at by now. But half of 4 is 2, and 2 squared is 4. So you're going to actually put a little plus 4 there. But if you're adding 4, how much are you really adding because of the 4 on this side? Right, 4 times 4 is 16. So technically you're adding 16. Now on here, half of negative 6 is negative 3. Negative 3 squared is 9. So you're going to add 9. But actually 9 times 9 is 81. So to clean it up a little bit, you end up with 4 times, we're going to do x plus 2 squared plus 9 times y minus 3 squared equals, and on the calculator you put all these together, the negative 61, the 16, and the 81. And you end up with 36. He's absent. Okay? Because it's an ellipse now, what are we going to do next? Divide everything by a 4, a 9, or a 36? A 36. Good job. Divide everything by 36 because we want it to equal 1. So go ahead and do that. And because I don't have a lot of room, guys, I'm going to actually write my answer up above the graph. So my reduced equation. 4 divided by 36 is 1/9. So this is actually going to be x plus 2 squared over 9. And this becomes y minus 3 squared over 4. And 36 divided by 36 is just 1. So there's my actual equation. Now by looking at this, just kind of a reminder from yesterday, what's the center then of this equation? Looking at it, it's what? Negative 2, 3, excellent. The other thing I taught you yesterday is that in an ellipse, a squared always goes with the biggest number, right? And a squared goes with the major axis. So this is going to be considered a squared, and it's always better to label it, and this is b squared. Well, knowing that, okay, what is the length of a? Which direction are we going to go with a? Positive and negative what? 3. So and which axis? Right, so on the x-axis, we're actually going to slide plus and minus 3. I'm going to write which axis it is down here because a is the major, and it tells me that it's the x-axis. B always belongs to the minor axis, which in this case, I'm going to slide up and down 2, and it belongs to the y-axis. So let's actually plot my ellipse. I'm going to start at negative 2, 3. And I like to look at this equation to graph my ellipse personally. I like to say, okay, on the x-axis, I need to slide 3. That's where I look. But you can look wherever you want. It tells you right here, too. So on the x-axis, you're going to go 3. And on the y-axis, I'm going to move how much? 2. It's just barely an ellipse. right? It means kind of like our demonstration we did the other day, like with the push pins. I didn't pull the push pins very far, right? The farther you take the foci, or the push pins, from the center, the more elliptical it looks. The closer your push pins or your foci stay to the center, the less elliptical your picture is going to look, right? So my next step is to actually find the foci. In other words, where are the push pins? How far were the push pins slid out? Okay? Now we find that by C. And remember yesterday when I was taking the string going around to make the ellipse, what did the string always form all the time? A what? A triangle, which is where the C came from. The formula defined C. All right? Do y'all remember from yesterday what it was? C squared equals what? Yeah, the biggest. A squared minus B squared. Good job. In an ellipse, that's how you find C. C, guys, represents how far did I slide the push pins. That's what they mean. C is the distance from the center to the foci. How far are you moving them? Right? That's what C is. And it can be found by this. So in other words, I want to do 9 minus 4. So C squared is 5. So C is the square root of 5. Okay? So C, we're going to write plus minus 5. Square root of 5, I'm sorry. Now because we're actually graphing that, let's get a decimal value for it. What is the square root of 5? 2.2. Yeah, 2.2. So it's approximately 2.2. And now then, to find the foci, okay, the foci is actually 2 points. So here we are. Here's our 2 points. We're going to go over here and on the major axis. So in other words, which direction are we going to slide it?
X.
The X. So on the X-axis from the center, you're going to go 2.2 to the right and 2.2 to the left. So here we are. I use a different color, but they're barely going to fit in. There they are. Okay? And then the hardest part kids have trouble with is actually identifying the point. So pay attention to how I do this. You can do it whichever way you want, but here's an idea to help you with this. If you think about this, here's my center, negative 2, 3, right? I'm moving those foci left and right. When you move points left and right, which of the ordered pair does it adjust? X or Y when you move left and right?
X.
The X. So the Y value of the foci should stay the same as what it was before. So 3, 3. The Y value is just going to stay the same. It's the X value that changes. So for example, I was where? Where was I originally? At negative 2. I was at negative 2 and then I went to the right root 5, didn't I? I slid to the right 2.2. So that means I want to be negative 2 plus root 2. Then I was at negative 2 and I slid to the left root 2, which would be negative 2 minus root 2. You'll notice you can't put those together. You're going to have to leave them. You can't combine them and have the exact answer, right? Negative 2 plus root 2 doesn't make negative 2 root 2. You can't put them together anymore. Okay, it's kind of like saying, what is x plus 3? Is it 3x? Oh, it's root 5. I see. Thank you, guys. That should be root 2. I'm sorry, that should be root 5. Thank you, girls. Because I slid root 5. Okay, what's the length then of the major axis? What's the length of the major axis? 6. And what's the length of the minor? 4. All right, let's go to the next one. Actually, I think for time, I'm going to skip number 2. Let's go to number 3. Okay, because I think we're just doing the same thing over and over, and you guys are getting pretty good at it, okay? So we're going to skip number 2 and go to problem 3. It says don't worry about graphing it, okay? Just actually get it in this form of an ellipse. So what's my first step? It's actually to combine the x's together, right? So we're going to take 16x squared minus 160x. It's an ellipse. We're going to put a plus in the middle. And then we're going to group the y's. 36y squared plus 432y. and I'm gonna move my 1120 over to the other side. Your next step is to complete the square. Agreed? Can I complete the square though? Without, what do I have to do first? I gotta get rid of the 16 and the 36, right? You're not allowed to have that leading coefficient. So in the first one, let's divide by 16 to give me x squared. Okay, and then you take 160 and you also divide by 16 to give you 10x. And then I'm gonna get rid of the 36. I'm gonna divide that to give me y squared plus 12y equals still my negative 1,120. Then I'm gonna complete the square, right? So half of 10 is 5, and 5 squared is 25. So this is like saying plus 25 right here. But it's not technically, this is what's gonna throw you off. It's not actually 25, it's 16 times 25, which would be 400. Down here, on the y's, half of 12 is 6, so you square it and you get 36. But really it's 36 times 36, which is 1296. Okay? So let's finish the problem out. So 16 times x minus 5 squared plus 36 times y plus 6 squared equals, and on your calculator, you're gonna add all these together. Good, and you get 576. Okay, what's my next step, guys? Right, what does it have to equal? Do I need to get rid of the 16, the 36, or the 576? What do I need to? Right, it's gotta equal 1. So I'm gonna divide everything by 576. So 16 divided by 576 gives me actually 36. 36 divided by 576 gives me 16. And there's your 1. That's your final answer. Which axis is major, guys? What's the major axis? X. Okay, now then, let's flip it over and let's look at problem number 1. Write the equation of the ellipse with the information given. And actually, sometimes you have to dig really deep in order to get these problems right, okay? And sometimes they're really easy and it gives you everything nice and pretty. This is a nice and pretty problem, right? It tells me the center, and it gives me A and B, and it tells me that X is the major axis. Now, what have we learned? Okay, what letter goes with the major axis? A. Okay, A goes with the major axis in an ellipse. Okay, so I know the first part's going to be pretty easy. I've got the center, so I'm just going to say, all right, that's going to be x minus 3 squared plus y plus 8 squared equals, we know it equals 1 because it's an ellipse. Now we just have to decide what belongs underneath each of these. Well, first of all, it tells me that x is my major axis. So x and A go together. So what do you think I'm going to put underneath here? If A is 7, what belongs under here? 49. Good. You have to square it. A squared goes there, 49. And then here, if B squared goes below here, what does this get? 16. All right, good. All right, now then let's go to number 2. It says that the center is at 2, -5. It says it has a major axis length of 14 and it's parallel to the x-axis. If my major axis is parallel to the x-axis, what's the major axis? X. So you might want to write that major axis is the x. And the minor axis length is 6. Well, I need to know what A and B are. What do you think A is? The major length is 14. What's A?
7.
Good. It's 7. The whole axis length is 14. So how much is just A? 7. And then the minor axis length is 6, so the whole length of the minor is 6, so what's just B? 3, half of it, 3, right? Now then, let's write our equation. X minus 2 squared plus y plus 5 squared equals 1. And the major goes with x. So a squared goes under here. What's a squared? 7 squared is 49, good. And then b squared would be 9. Okay.